This week, we're talking about one of the most fundamental technologies underpinning today's data protection systems, and that's replication. What is it? How is it different than other methods? And if it's so great, why don't we just use it for everything? And of course, what's the difference between synchronous and asynchronous, and why does that matter? Hi, I'm W. Curtis Preston, aka Mr. Backup, and I've dedicated my 30-year career to helping people like you keep your data safe from all that would do it harm. This is the Backup Wrap-Up.
Could restore it all and rescue me from pain. You had my file inside. You erased it. How insane.
Welcome to the show. With me, as always, is a guy who seems to never be happy until I have problems. Prasanna Malaiyandi. How's it going,
I'm
Prasanna?
good. I'm just trying to think, what problems do you have right now?
I'm trying to edit the podcast, and you're giving me problems about my network. That's what I'm talking about.
Yeah, what I do. You need someone to ask the hard questions.
Somebody's got to do it. The network's going all right. Those that have followed, I do have this new tool. I have the Firewall.
Version 125 of Curtis's home network architecture.
Yeah, but I now have this Firewall that gives me a lot more information than I had before. And unfortunately, it verified my new ISP's thing that I use too much internet and I have to buy the unlimited package, which is sad because it's another $50 a month. But anyway, so let's get to the news of the week. I'm going to let you take the first story. Prasanna,
Yeah.
you wanna do
So
that?
the first one is an article that came out recently. It is about a backup company. I guess, would you call them backup or data protection company that recently raised a round of funding? It's called Alcyon. I actually used to work with the founder previously at an old job. And they actually raised a round of funding, and it was actually led by Veeam, which is interesting because Veeam, as we all know, is also a backup company, and they are investing in Alcyon, who is primarily targeting backups for Microsoft 365 for SMB customers.
Today, that's their initial target market. I'd say the biggest difference between the two companies, one is a software product, the other is a SaaS offering, and that makes them very different. And I guess Veeam felt that it was different enough. I like the quote in the article. It said something along the lines of that from Veeam, that this problem of ransomware is a big enough problem that we're going to need the whole industry to solve it. And so they invested in what is essentially, I would call it a partial competitor, right? They do compete for the Microsoft 365 space. I also know the founder as well. And I think they've taken an interesting angle with a very AI-based approach, a very security-based approach.
Yeah, and one of the things I'm actually looking forward to is seeing if this is going to force other vendors to reconsider how they approach the problem. And all the vendors raise the bar when it comes to ransomware protection and detection and other things like that, which we all need, right?
Anybody that's listened to this show knows that we're concerned about that problem. My second news story, it's from the Enterprise Strategy Group, which for those of you who have known ESG for a while, they were a few years ago acquired by TechTarget. And there was a 2023 survey of IT professionals. The most interesting number that I see here is that they said 65% of the almost 400 respondents said their organization were using some sort of cloud-based backup system. And the way they worded it, that could be either a cloud-based service or they're storing a copy of their backups in the cloud. That, to me, really, that's a very different number, wouldn't you say, than
definitely.
2 years ago?
Yeah, everyone would be like, I don't trust my data in the cloud. How do I get my data up into the cloud and bring it back? And all the rest of that. In fact, I think one of the interesting things was even just the title of the article, right? It's like Cloud Backup and Disaster Recovery Evolved Toward Maturity. That just kind of says it all, right? Versus before, you're fighting tooth and nail with customers trying to persuade them, hey, it's okay to store your data in the cloud.
Yeah. So the not so good number was they're saying that half of the surveyed orgs recovered 75% or less of their cloud data per incident on average. That sounds really bad.
But
That is not, I agree with Christophe Bertrand, which said that's just not acceptable for such a mission critical
but I guess
product.
the question I would have is, it would be, we probably need to compare that to what's your recovery rate of on-premises backups, because that's not going to be 100%. And then I think it's also not
Right.
fair to compare it, because how long has traditional backups been around and had time to evolve versus cloud backups, right? It hasn't had that time to evolve and mature fully as these other products.
Yeah, I would say that having formerly worked at a cloud data protection vendor, I would think that the problem that I see with this number is that they do conflate people storing backups in the cloud versus people using a cloud service. I would be very surprised to learn that people that are using a fully cloud-based service, if their recoveries failed, because it's really the cloud just happens to be a part of it. All of the same sort of misconfiguration problems that lead to problems with traditional backup are going to bleed over into a cloud setup. Just because you're using cloud isn't going to make
it's the
that
cloud.
any
It's
better.
magical. Come on, Curtis.
Yeah, it is magic. The one other interesting number from this survey, there were some other interesting numbers, but just for brevity purposes, this other interesting number, they said 16% of the respondents said that they reviewed their cloud data protection strategies annually. That's a very different number than back in the day. Back in the day, that number was like 5 years, maybe 3 years, certainly not annually. Backup historically has been an incredibly sticky process. And this idea that they would review it annually, I think is a pretty
I think
big deal.
it also makes sense, though, because like with the 5 year, 3 year, 5 year, right? You have to worry about hardware depreciation, right? Upgrade cycles, all the rest. With cloud, right? There might be new technologies, cheaper ways to do things, right? Your workloads might change. What you had running on premises might be migrated to the cloud. Now you have to reconsider, how do I back it up? And so I think that's probably why looking at these things more frequently, like annually, probably is starting to make a lot more sense.
Well, that is the news of the day. On this episode of the Backup to Basics series, we're going to be talking about replication, different kinds of replication, the good things, the bad things, and what they have to do with backup is it a backup? Right?
I thought you were going to talk about like the replication technologies that they have in like Star Trek, and right where it's like, create me.
No, that's not replication. What is that called?
What are those things? The
Transporters?
No, the thing
no.
the making the stuff, right? The food.
Do they call them replicators?
Yeah.
I think they call them replicators. Yeah, we are not discussing replicators like in Star Trek. Although those do sound magical, by the way. And by the way, like if you can do transporters, of course you can do replicators, right?
Yeah.
Because all replicators is storing a backup copy of the food and then saying this is what it is, right?
Do you think that they have backups of those backups?
Of the people?
Copies? Yeah, no, of the copies of the food. Because imagine you wipe out the copies and then you basically killed off humanity because they wouldn't have any way to make food.
I don't
or maybe they're immutable, or maybe they're immutable copies.
Maybe they're immutable copies. I would hope that no one can go in and change the food before it gets replicated.
On to a more serious matter.
Well, so we've moved on. The previous episodes we talked about sort of regular kind of backups, and they were backups that require a restore. Basically, is what we were talking about. We've now moved on to types of backups where the restore is essentially already done, right? And replication, and so I'm putting these. And by the way, for those that don't know what I'm talking about, we are basically working our way through this book, Modern Data Protection, which is my book, which is available, wherever books are sold. And I might even put a link in the show description there. And the idea here is what we're talking about is methods of backup. And again, remember, when I say backup, I'm very broad in that term. Methods of backup that support instant recovery. Do you want to talk about what instant recovery is?
Yeah. So normally when you think about you took a backup, something happens, you need to get back your data, right? If you had your data stored on tape, you got to go fetch the tape, you got to pull the data off of tape, copy it somewhere else, and now you actually have your data and you could do something with it, right? With instant recovery, it's really your data is already available for you. You don't have to have any sort of processing that you have to do before you can actually start accessing your data.
Yeah. I mean, it's a beautiful thing. I think that maybe I dream that sometime in the future, this is the way all restores will be done, right? And the cloud really does make this possible. We could talk about that all day long, but we just need to work through the different ways that we're going to create an always on, readily available copy of the data. And the first that we're going to talk about is
before you get there, though, I think one important point to cover is I know you said in the future, maybe everything will be like this. Right? I think if you had a gazillion dollars, yes. Right? Because there is a cost associated, right? Which I think is important to cover, right? With sort of using these various technologies that might make it more difficult. Now, like you said, maybe the cloud helps with some of these, but there is still a cost associated with keeping data on something that is instantly available versus, say, using a tape or some sort of offline media, where the cost may not be just the cost of the storage, but think about from power, cooling, right? All those other aspects as well.
Yeah, I was speaking in the future when these problems have all been solved. I think even today that there are services, there are cloud storage services that, if used properly and judiciously, can provide you a ready-to-go copy of your data for pennies on the dollar that cost you, next to nothing to have and to possess and to have it ready to go. You will then pay through the nose if you use them. Right?
Yeah.
I'm thinking, of course, of like Glacier, Deep Archive, Instant Recovery.
Yep.
Right? There are services that are still storing the data on disk, but storing it in such a way, I don't know. We don't, neither of us have ever worked at AWS or any of the cloud providers, but they're storing it in such a way that they've made it so cheap to have that copy, to have it off site, to have it in, in another region. I just think that as that continues to happen, that we will eventually get to a place where all DR copies can be held like this. Can I have a dream, Prasanna? Can I have a dream?
Yeah, you can have a dream. But I think, but before we also continue on, I think we also need to define what we mean when we say instant, right? Because instant,
what?
When we say instant recovery, right? I think it's helpful to talk about that because instant is a spectrum. Right? Like you were talking about for your Glacier Instant Restore feature, right? It's not like, oh, I want my data. It's available within, like, snap my fingers, it's there, right? It does take time, but that time may be acceptable to you, right? It might be, say, minutes, not days.
Right. Yeah. So instant is kind of like continuous. It's a binary condition. It's sort of like immutable. It's a binary condition. It's like pregnancy, right? You're either pregnant or you're not. And so it's either instance or it's not. But it's yet another one of these terms where it's not truly binary,
Yeah.
right? It's just we're defining instant recovery. And this point is I don't need to do a restore to do the recovery.
Yeah.
The data's already been restored. It might take a few minutes to make it accessible to me.
But yeah, sorry. And just for people who may not have heard our previous episodes, do you want to quickly cover differences between restore and recovery since you just talked about it?
A restore is essentially the act of bringing back the data and putting it in place. The recovery is the process of sort of bringing that data online and using it. And sometimes that recovery involves massaging other things. It involves massaging the data, and it involves doing other things. When you're done with the recovery, everything is working again. When you're done with the restore, everything is ready to be working again. So depending on how good or how complicated the restore is, the two may be, they may happen at the same time, but in a complicated situation, you do the restore and then you do the recovery.
Okay.
In this case, the recovery would be this instant of, like I said, just
everything's ready to go. Or sorry, everything is available.
Yeah, exactly. We don't have to do a restore.
Yeah.
And I would say that in a true instant recovery, the size of the thing being recovered should not be a factor. Whereas in a restore, it very much is a factor.
Oh, yeah.
Right? Yeah. Okay. So with that in mind, we're going to talk about the first method that could be used and is used, actually. It is used quite a bit to do an instant recovery. Now, as we often do on the show, let me take you back in the day. Yeah, so back in the day, there was a very sharp dividing line between backup and recovery and disaster recovery. And for backup and recovery, for what we also call operational recovery, you had a backup system. You went to tape, and when you did a restore, you came back off of tape. Anyone with a tight recovery time objective would never build their DR system based on tape back in the day, right? Even as we move to disk-based backup and recovery systems, anybody with a tight RTO is not going to build their disaster recovery system built on having to do a restore first, right? So back in the day, if you worked at like a financial trading firm or something like that, and you wanted to have a disaster recovery plan, because of course you wanted that because you had the OCC that was looking into you and they could say we're not a bank, right? You used replication.
Yep.
You had a backup and recovery system that did operational recoveries and file recoveries and maybe even recovering an entire server. But if you had data that truly mattered, you used replication. And I know you worked at a company that...
Yeah, that was my first job out of college. Yep.
Yeah. So let's talk about what replication is. How does it typically manifest itself? Do you want to just sort of define what replication is?
Yeah. So replication is basically taking data, making a copy, and sending it off to some other system, right? At a high level. Now, there's various nuances and combinations. That other system could be the exact same vendor, the same model, all the rest as the original. It could be a different vendor, right? A different system, right? So there are different ways you could do it. There are different protocols for transferring that data. You could use protocols that some of these vendors have built in for communicating between them to make things more efficient. Because when you have to send data across from one system to another, doing it over and over, because it's not like it's a one-time operation, right?
Yeah, if I could interrupt, I think that's one word missing from your definition. If I could insert at the beginning of your definition the word continuously.
Yeah.
Right? Because anybody can copy the data over. I think replication implies that we're continuously copying it over. The idea is that it's happening all the time.
Yes.
Right?
Yep.
We're going to talk about the difference between asynchronous and synchronous. So sorry for the confusion for those, but basically you have some data, in A, and you have a copy of that data in B, and that B copy is continuously, for lack of a better word, updated to be the same exact thing as what's in A.
Yeah. So going to Curtis's disaster recovery scenario, right? Something happens on system A, right? System B has a version of what system A looked like at a point in time, and you can fail over to system B. And that's how you're instantly up and running because system B looked like system A. I think one
Yeah.
thing we should also cover, which I want to talk about earlier, I know you threw out the term recovery time objective. I think another point to talk about here is also recovery point objective, right?
Yeah. Well, go ahead.
Yeah.
You brought it up.
So, yes, in the case of when you're doing synchronous replication, yes, there's still going to be an RTO on that, but that RTO you should be able to measure in seconds to minutes, depending on how long it takes you to bring up system B and make it available for your applications and other things. So that's kind of like
Right.
RTO side. Do you want to talk about the RPO, Curtis?
Yeah. So the RPO is basically the amount of data that you agree that you can lose, right? The recovery point objective is, we say we can lose an hour's worth of data. We can lose a day's worth of data. We can only lose 5 minutes worth of data. This is, you're setting your recovery point objective. To what point must you recover? And the fastest RPOs in the business are going to come from these types of products that we're going to talk about in the next couple episodes. The first of which being replication. With a replication system, you could get an RPO. You could meet an RPO that's as close to zero as possible.
I've actually seen zero.
I'm sure you can do zero. It's just that
So I'm going to talk
could happen, right?
So it's in a very, very unique case. So I don't know if you're aware of this. There is a mode on some systems called domino mode. It's out there in the industry, right? Mm-hmm. And basically what you're saying is every time I accept a write on system A, I'm going to make sure it's replicated. It hits system B. It's acknowledged before system A acknowledges a client. In this case, so you're guaranteeing every single write.
It's like a two-phase commit for storage.
Yep.
Right. A two-phase commit is a term from database world, which makes sure that it's written both to the log and it's written to the, before you acknowledge that the transaction has happened.
It's high latency, very expensive, but if you have those requirements, there is an option. But like you said, most people will.
So the question is, what matters more to you, performance or never losing any data?
Yep.
Right. So speaking of which, let's talk about the difference between synchronous replication and asynchronous replication. Synchronous is basically what you just described. That, it's not necessarily what you just described.
Not fully to domino mode.
We are going to replicate every byte as it's happening, right? And literally every single, the moment a change happens here, the change is going to be replicated to the destination, to the target.
Yep.
Right. And the good side of synchronous replication is you're going to have the smallest RPOs possible, right? Including, I guess I was aware of it. I didn't know that I didn't know the term dominant mode, but I was aware of that idea. This is going to give you your tightest RPOs possible. The challenge with this is a little thing called the speed of light. So it takes one of the things that we know is that we want the recovery copy to be some distance away from the primary
copy. In the same rack?
Not in the same rack, not in the same town. There are sadly some stories from 9/11 where there were companies that had their hot site, which was a synchronously replicated copy of their data, in the other tower.
Yep.
And so there were companies that ceased to exist on 9/11 because they lost both their primary and their secondary copy, right? You don't want to have the two copies in the same place where a disaster could wipe out the entire town, a flood, earthquake, whatever. And so you want to have some distance between the two. Now, after 9/11, I don't know which governmental organization, but after 9/11, the Fed, the federal government, not the Fed, when we say the Fed, or you know what I mean, the federal government started to dictate that a synchronous copy of the data needed to be stored more than, it was like 250 miles.
Yeah.
And everybody basically came back and said, that's not really feasible.
Yep.
It's possible, but not feasible, because going 250 miles at the speed of light, every single time you replicate, every single time you update a block on every piece of storage, basically really pulls down the performance of the primary system.
Yeah. And the other thing to also mention is when you're doing synchronous replication, you want to make sure that your destination system, right, your replica copy, is as performant as your primary copy.
Yeah.
Right? Because otherwise, if it starts to lag and slow down, eventually you're going to start falling further and further behind. And usually these technologies, after a while, they'll just stop accepting writes and they'll kind of fall back into like an asynchronous mode and have to then catch back up, right? Which you don't want because that affects your RPO.
Yeah, you don't want. Yeah. So it's got to be basically the same, if not better, performance on the backup system, which is crazy talk to most people.
Yeah.
Right. But that is, if you want an RPO of 0, synchronous replication is literally your only choice.
Yep.
Right. Let's talk about asynchronous replication. And that is basically not that. So we're going to build essentially a buffer of writes as the, you know, and we try to not let the buffer get full, right? What it does is it disconnects the writes on the other side with the writes on this side.
Yep.
We may and will try to keep up with the pace, but writes can continue to update, and you might get a spur of writes on the primary side, and then they fill up the buffer, and then the buffer gets emptied. And that, I think, works as long as essentially your bandwidth and your latency is sufficient.
And
But go ahead.
And I just want to chime in that I know you called it async, and async threw me for a while because in my mind, async is different, but that's just based on my background, right?
Okay.
Other vendors might refer to this as like semi-synchronous, right? Where it is not fully synchronous, right? But it's not.
And it's not synchronous. Asynchronous means not synchronous.
I know, but this is just some vendors. So if you are looking at vendor terminology, right, and looking at their vendor technical specs, so here's a question for you, Curtis. What are some things that a user can look at for a vendor's technical specs to determine if they support async replication, like what we're talking about right now?
Well, I mean, I don't know what other words they would use to describe it.
So I know NetApp uses semi-synchronous for what you're describing.
Whatever.
I know.
That's just marketing BS. Okay, it's either synchronous or it's not synchronous. You're either replicating everything as it's happening or you're not. Okay, so the question to the vendor is can my target copy ever get behind my primary copy? Right.
Yep.
And if the answer is yes, and it's like, well, how much are we talking? Right. So the question is, because that's going to determine your RPO.
Yep. So that's actually the key. Yeah.
Yeah, exactly. So if you can build up a buffer of an hour of changes, you could lose an hour of changes on the target end if you lost your primary.
Yeah.
Right.
So what if you said like, so then I'll take back my comment. In your mind, though, if I said I want to have a replica copy updated and my RPO is 8 hours, that's still async?
Well, what else would you call it?
Okay, no, just checking.
Yeah. I mean, again, you're either synchronous or you're not,
Okay.
right?
So then I take back my comments, right? So if I look specifically, that's why I just wanted to make sure.
You stand corrected, sir.
Yes. So if I look at, sorry, I'm more familiar with NetApp and NetApp's replication technologies, right? But if I look at NetApp, right, they have synchronous, which we talked about, which matches perfectly with what we were talking about.
Right.
They have semi-sync, where it allows some amount of lag. I think it's up to 60 seconds,
Right.
right? But it does,
Right.
like what you said, buffering. And then they have sort of their async, right, where it allows you to go beyond, I think it's from 5 minutes to, you could set a replication every 5 minutes to days.
Yeah. And those are just two different, those are just both
Technology.
asynchronous with different settings,
Yep.
as far as I'm concerned.
Yep.
And you could also, like, if you were a NetApp, and I don't think they do it like this, but if you waited until you took a snapshot and then replicated only the bits necessary for that snapshot, that's still kind of asynchronous.
Yeah, that's just a technology.
But,
that's a means.
Yeah. But generally here, we're not talking about snapshots and things, because that's what we're going to talk about in a following episode. Generally, what we're talking about is two, block devices that are being continuously updated to be exactly the same with possibly a lag. If there's a lag, then it's asynchronous. If there's no lag, then it's synchronous.
Does it have to be so I'm going to ask another question. So,
man, you are difficult.
I know I am. So you said block devices. Would you consider anything that also replicates a VM at a VM block level?
Yeah.
To also,
in the end, it's still a block device underneath.
Okay.
Right? It's not what we're replicating. It's just that we don't have this conversation when we're talking about object.
Yeah. Or files.
Right? We don't even file replication, we don't really talk about synchronous and asynchronous when we do file replication, I don't think. I think that's always asynchronous. At least I don't think so. I think this is generally a block discussion, right? There may be exceptions to that rule, but generally this is a block discussion. Even if this is a NetApp, right? Really what you're replicating underneath the NetApp is file. It's a file device, but underneath you're replicating blocks.
Yeah.
Yeah. All that discussion just from one word.
Yes.
So you can also have a hybrid of these two things. Can you think of an example of that?
Yeah. So take your bank example, right? So you're a financial customer in New York. You want to make sure that your data is synchronously protected to someplace nearby. So maybe you go over the river to New Jersey using synchronous replication. And now you need to make sure that you're protected in case something happens in the East Coast. And so you might use async replication and send that copy off to, say, Utah.
Is that when we go through the woods?
Yes.
See what I did there?
Yes.
Over the river and through the woods. Yeah. So you might, and that was, I remember back in the day, we had a synchronous copy that was literally like right next door. Yeah. I mean, literally, and when I say next door, I mean, like it's the next rack over. That was like a synchronous replication. And then actually, what you remember, Symmetrics and or EMC and NetApp, you'd have like 4 storage arrays, right? You'd have
you can have a lot more. Yeah.
You'd have the synchronous that was right next to it, the asynchronous that was down the street, and then another asynchronous that was the other. Yeah.
And sometimes there are customers who could use it for like data distribution use cases, right? So I need to make sure that my database is available locally in different countries. So I'm just going to replicate it all.
Yeah. So synchronous, both forms of replication have a lot more applications than just backup and recovery. Right. So I'm glad you mentioned, or you asked me about VMs. There is another not file and not VM thing that gets replicated, which is where we still have sort of the same discussion about synchronous versus asynchronous, and that is databases.
Application level synchronous.
Right.
Yeah.
And I'd say that, in that case, basically, when we, again, that can definitely have two-phase commit, right? So in the database world, you're replicating a transaction or something. I don't have a better word. I know not every database has transactions, but I don't have a better word for that.
It's the atomic
You're
unit, whatever it
replicating
is. Or sorry, the unit of
yeah,
whatever
an
it is.
atomic unit of a thing. You changed a thing in the database, right? And you're replicating that rather than the blocks underneath. And well, you could be replicating the blocks underneath, and that's what we're talking about over here. But at this point, we're talking about database level, application level replication. And when you do that, you have the choice of either immediate consistency or eventual consistency, which is essentially analogous to synchronous and asynchronous, right? And what made me think about it was when you were talking about that there are other reasons that people replicate, and there are databases that allow replicating data, across the world. And the best example that a lot of people are used to is the DNS database, right? That is an eventually consistent, replicated system. If you've never made changes to DNS, let me tell you, it can take a minute. Right? I recently, literally in the last week or two, I've been making changes to various websites that I own to, change their DNS entries and CNAME entries and things like that. And they don't all immediately happen.
They eventually get there, but
what's that? Yeah, they will eventually get there. That is essentially the database equivalent to asynchronous replication. Now, let me ask you a question, Prasanna. If replication is so amazing and we can have the tightest RPOs, and I think we can agree that tighter RPOs are better than looser RPOs, right? An RPO of 0 or a minute is way better than an RPO of 36 hours, which is what we typically get with a backup system. Why don't we do replication for everything? And by the way, money is not the issue.
You knew what I was going to say. Right?
Well, it is an issue besides money, right? Because replication is expensive.
So
why don't we do this?
So the biggest problem with replication is for most of the replication technologies, when you replicate it, you only have that one copy on your target system, right? And so if you had a user who dropped a database table and you replicated that command over to your replica, guess what? It gets dropped on your replica as well, and you have no ability to recover. And
exactly.
So that's one of the biggest limitations of relying on replication. Or at least,
and the same would be true of any change on the primary system, which includes things like ransomware. Right. So if there's a hacker goes in and deletes all your tables or just corrupts your data, deletes all your files, whatever, it just, if a virus does it, whatever, if there's any kind of cyber attack on the primary system, it simply makes that attack more efficient.
And because the entire purpose of replication is to create a duplicate copy on your target system, right?
So immediately available. Right. You asked for an RPO of 0, you're going to get an RPO of 0.
Now, I will put a caveat that wait until we talk about snapshots. We will come back to this specific point.
Right.
But
there are backup data protection based systems that use replication at their core and don't have this problem. This is just replication, right? It's like, why don't we use RAID for everything and then we don't need backup? Well, same exact reasons, right? Exactly. RAID does help with media failure and equipment failure and site failure and power failure and. But it is completely defenseless against cyber attacks and stupidity.
Or logic issues.
Well, you're being nice. See, this is why you're
I was thinking software bugs, not user logic.
Oh, okay. Well, that's still stupidity. It's just, different. It's the person who made the bug. Well, this has been fun. But yeah, this whole thing of this idea that replication is where we're continuously updating the data. Now that you see like this idea of why we were wrestling over the word continuous, right? Because is asynchronous continuous? I think it's still a continuous process.
Yeah.
It's just continuous with an asterisk.
Yes.
Continuous with a buffer. And I think that, well, in fact, I know that replication today is way better than it was back in the day. Back in the day, you had to have the same vendor on both sides. It sold a lot of EMC,
Yep.
right? You had to have the same vendor because the replication was based on the box.
Yep.
And now there are a number of products, one of which we've had on here, right? We had Data Core on here, which does replication between, disparate different architectures. You can have a very expensive primary system and a less expensive target system. You can use it as a way to upgrade and move your technology. You can move your older systems to be the target system, knowing that if you need to use it in a disaster, you will suffer a performance loss, but you don't have to, like you did back in the day.
It's
you
not
don't,
an outage.
When you primary, you don't have to have the same, and so you get cost savings.
Yeah.
You don't have to do it that way, but it gives you the flexibility. And I think that modern day replication systems are much more forgiving of things like, outages and things like that. Right. But they still don't protect you from,
Yeah.
mistakes and cyber attacks, which is why we have to talk about the alternatives,
Yep.
which we'll do on later episodes. But so you were you were excessively argumentative in this episode. But I thank you anyway.
That I try. I basically spent almost all my career working on replication technologies. So
Yeah, and I you worked at a company that was trying to say, well, there's asynchronous and there's near synchronous, and I'm like, those are two words for asynchronous.
yes.
As I was editing this episode, I realized that I was being a little too pedantic about continuous or not continuous. The thing with replication that really sets it apart from other data protection technologies is that the copy is an actual copy. It looks exactly like the original, unlike what we do in the backup world where we tend to put stuff in a container or something like that. That's one big thing that separates replication from other backup technologies. And then also the idea is that it is incrementally updating, that whenever we do it, whether it's continuous, asynchronous, or even periodic, I really forgot about how there are vendors like NetApp that actually do periodic replication. There's nothing wrong with periodic replication. It's still replication. So you've got continuous, asynchronous, and then periodic. What sets replication apart from everything else is this: whenever we do the next replication, what we're doing is we're transferring the things, whether it's database records or blocks, we're transferring the things that have changed since the last time we replicated. So I hope that helps unmuddy the waters just a little bit. You're either synchronous or you're not. Just like in a following episode, we will be talking about you're either continuous or you're not continuous, right? We're going to talk about a term near continuous, which I actually coined, but a lot of people think isn't a thing.
Yeah. I don't know if I believe in that.
They're like, you can't have. Then again, they'll say that continuous is a
spectrum.
Is a binary condition. So anyway, well, I want to again say thank you to our listeners. You are why we do this. Remember, this is an independent podcast, and the opinions that you hear are ours. I hope this episode has been helpful. that's a wrap.